4.3 Use of Poisson distribution to approximate binomial distribution. The binomial distribution converges towards a Poisson distribution as the number of trials goes to infinity, while the product NP remains fixed, that is, P is very small. Therefore, the Poisson distribution with parameter lambda equals to NP can be used as an approximation to binomial NP of the binomial distribution if n is sufficiently large and p is sufficiently small. Given that x follows a binomial NP, if n is large, that is to say, n is more than 50 and p is small, such that the product NP is less than 5, then we can say that x follows a Poisson distribution with lambda as NP approximately. Example 16 will give us an illustration of how to use approximation. A factory packs bolts in boxes of 500. The probability that a bolt is defective is 0.002. Find the approximate probability that a box contains 2 defective bolts. Now, just by looking at this question, we know that x follows a binomial distribution with n as 500 and a probability as 0.002, which is rather small, and n is large. So, let us define the random variable, which is the number of defective bolts in the box. So, x follows a binomial with n 500 and p 0.002. Since n equals to 500, which is more than 50, and np, which is 500 times 0.002, which is 1, and is less than 5, therefore, x follows a Poisson distribution with lambda as 1 approximately. To work out the probability of x equals to 2, we have to call the Poisson distribution PDF, and substituting lambda to be 1 and x to be 2, you end up with 0.184. Example 17. Each week a security firm transports a large sum of money between 2 places. The day on which the journey is made is varied at random, and in any week each of the 5 days from Monday to Friday is equally likely to be chosen. Part 1. Calculate the probability that in a period of 10 weeks, Friday will be chosen at least 3 times. Part 2. The event that in a 4-week period, the same day is chosen on all 4 occasions is denoted by S. Show that the probability of S occurring is 0.008. Estimate the probability that in 100 4-week periods, the event S will occur at least 3 times. Part 1. Let us define x be the random variable, the number of times Friday is chosen in a period of 10 weeks. Therefore, x follows a binomial if n is 10 and the success is 0.2, which is 1 over 5. To find the probability of x more than or equals to 3, we need to convert it to less than, which is 1 minus probability of x less than or equals to 2. And using a GC with binomial, CDF, you end up with 0.322. Part 2. Probability of S occurs means to find the probability of all Mondays plus the probability of all Tuesday plus the probability of all Wednesday plus the probability of all Thursday plus the probability of all Fridays, which is equals to 5 times 0.2 to the power of 4, and that will give you 0.008. We need to define another variable y with the number of times s occurs in 100 4-week periods, and therefore y follows a binomial with n as 100 and the probability of s occurs is 0.008. And by checking that n is large, which is more than 50, and p is small, such that np is equals to 0.8, which is less than 5. So y now follows a Poisson distribution 0.8 approximately. We are required to find the probability of y which is more than equals to 3. And we need to convert the more than as less than, which is 1 minus p y less than equals to 2. And using the GC and calling for the Poisson CDF, we end up with the answer as 0.474. Example 18. If x follows a Poisson 3.4, find the most likely value of x. Note, a Poisson distribution is bimodal if lambda is an integer, and it is unimodal if lambda is not an integer. Now for the most likely value, we have to use the GC to help us to work out by keying y1 as Poisson PDF, lambda as 3.4, and x, and calling out the table of values, which is shown on the right. With this table, we need to look out for the one with the highest value, which is 0.2186, and this corresponds to value 3. So using a GC and from the table, the most likely value of x is 3.